Greetings, mathematicians. In this video, we're going to be continuing our work with GCFs and LCMs and expanding that to monomials. So GCFs and LCMs, these are exactly what they sound like. So GCF stands for greatest common factor. So we're going to be looking for the common factors between two or more monomials, and we're going to be finding the greatest or the largest one. And then similarly, we'll be looking for multiples of a set of monomials. And we'll be looking for the smallest common monomial that's shared between those expressions. We'll start with a quick review of working with just numbers. So first we'll start by finding the GCF and the LCM of 60. Now, it's nice to do these together, so finding both the GCF and the LCM, because the work involved kind of overlaps a little bit. So our first step is that we're going to find the prime factorization of both of these. And you might need to be a little bit strategic because we want to try to line up factors that are the same between these two. So 24 can be broken down into 2 times 12. 12 can be broken down into 2 times 6. 6 can be broken down into 2 times 3. And then 60 is 2 times 30, 30 is 2 times 15, and 15 is 3 times 5. This is what I meant by where I said we want to kind of line up factors. So you'll notice where I left a space here because there was not another factor of 2 in the 60. Next up, we're going to find the GCF by finding the common factors. So where these are lined up, and we have factors that are in both 24 and in 60. So they both have 2 2s and 1 3. So 2 times 2 times 3, the GCF is 12. And then for the LCM, you take your GCF and now you multiply all the other remaining columns. You have a column for a 2 and you have a column for a 5. So 12 times 2 times 5, our LCM is 120. Here is another problem exactly like the last one. If you're feeling confident, go ahead and pause the video and give this one a try, and then come back and check your work. If not, you can stay here and we'll work on this one together. Remember, your first step is to find the prime factorization, kind of being strategic as you write them out so you line up the numbers. So here we have our 60 written out as 2 times 2 times 3 times 3. Our 36 written out as 2 times 2 times 3 times 5. Everything lined up. GCF, finding our stacks where we have things in common. So both numbers have common factors of 2, 2, and 3. So our GCF is 12. LCM, you start with the 12, and then you multiply the leftover columns. So we need another factor of 3 and another factor of 5. So our LCM is 180. Now before you try a couple of problems on your own, here's one extra vocabulary term. Sometimes when you go and you list out the prime factorization and you try to find things that are in common, you might find that there's nothing in common. If you find that there's nothing in common, remember that there's always a factor of 1. Every number is always divisible by 1. And if that happens, we say that those two numbers are relatively prime. So for example, 12 and 5 are relatively prime. If I listed out the prime factorization for 12, I would get 2, well, actually let's do this. So 12 would be 2 times 6, and 6 is 2 times 3. 5 is already prime, so it's just not going to go anywhere. It's just going to stay a 5. And we look at these numbers and we look at this number, and there's nothing in common. So the GCF would be 1. And anytime that the GCF is 1, then that means we say those two numbers are relatively prime. So this is just an extra vocabulary word for you here. So next up, we've got the your turn practice. Go ahead and give those a try and then come back to check your work. All right, just so you can check your work here, this is what you should have come up with, where you did your prime factorizations for each of your numbers, looking for the things that were in common. If there was nothing in common, then your GCF was 1, and then any extra values multiplied by the GCF, that's how you got your LCM. So we're going to stop at this point before moving on in the next video. Bye for now.